Okay, so welcome again to another one of these workshops in AI. Today we are with Gaston, one of our AI engineers and data scientists in Lenio. Hello, Gaston. How are you?
Hi, Jose. Hi to everyone. Thanks for listening.
Yeah. So today we are going to be talking about a little bit more on Stable Diffusion, right? Because we had already one talk about this by Fede, but this time we are going to try to control it. Um, Gaston is the expert here on ControlNet, so yeah, he's going to be leading the way.
Yes, in the last workshop, we talked about diffusion models and how it works. So today we're going to talk about how to guide this generation of images and how to make images that looks alike to the images we want. So let's see how this works.
Okay.
Okay. Today we're going to talk about stable diffusion and some diffusion models. And then we're going to get into what is ControlNet and how it works. And then we're going to talk about some models we can use to alongside stable diffusion. And then we're going to use in real time these control nets, and we're going to see some examples and some conclusions.
Okay. I guess we can use some questions from the audience to try to generate some images at the end.
Okay.
Yeah.
Okay. So in the last workshop, we talked about stable diffusion. This is a diffusion model. So it works denoising white noise with a condition. This condition is based on a text or a prompt we use. So from a text like teddy bears wearing suits discussing a business proposal around an office table, we got some images that are some teddy bears with suits. But what happens if I don't want this kind of images? If I want, I don't know, the teddy bears around a round table. Okay, here is when we need ControlNet. So it's another model that adds more conditions than the text to the generated image. So this condition is in many forms. Usually it's from features from another images like boundaries, pose estimation, depth maps. So, and here we have some examples like a segmentation map. This is, for example, a picture of a room with a chair colored in blue and a desk in green and different objects with different colors. This could be a picture, and we use a segmentation model alongside ControlNet to generate this, or we can make our custom color map following the color from the Coco datasets. And then we use
And
this
that's
to,
already
yep.
sorry for interruption, Gaston. That's already labeled, right? Like those colors mean something for ControlNet or something like that.
Yeah, the colors are fixed. You cannot use random colors to color any object you want. So you need to
Mm.
follow these color labels.
Okay.
And other options are, for example, scribbles, like you take a paper and draw something. And from these simple scribbles, you can get these amazing hyperrealistic photos. It's pretty cool. Okay.
So then summarizing, what you can use is contours, apparently depth maps, like in the scale of in a grayscale image, you can use that as a depth map to make a realistic image, let's say, and then you can use segmentation to put different things in different positions and exactly into those positions, something like that, right?
Yeah, that's right.
Okay.
Okay, but let's follow this example. So imagine we want to generate a picture of a dog in a specific position. we can start saying to Stable Diffusion like, okay, generate a cute dog. But this is a pretty cute dog, but it's not the dog we want. So we can make a little bit of prompt engineer, and maybe we say, okay, make a cute dog standing on 2 feet, and yeah, it's a cute dog standing on 2 feet, but it it doesn't look like the dog I want. So here is where ControlNet um, gets in help to get the image we want. So we can use another input alongside the prompt, like a scribble from a black and white drawing. So we have the scribble of the dog, and the generated image is going to be very similar to the dog we draw, and it's going to be more similar to the image we want. Okay?
Yeah, that's actually amazing because, I mean, I guess that everybody has struggled with this, trying to make DALI or Stable Diffusion or also Midjourney, trying to create the perfect image or an image that has some specific, let's say, pose or things into them, right? So
Yeah.
with this, you can just generate what you want, the exact pose that you want, and then you can just iterate on the style of the thing that you want to generate.
Yeah. You can use more simple prompts and get better results.
Yeah.
But how does it work? Okay, first of all, we have the prompt. It doesn't change. And then we have an image and use a small model to extract some features of that image. It could be the canid edge detector, like in this example, but it could be a segmentation model, a pose estimation model. It could be any model you want. And with that feature map alongside the prompt is we use to generate the final image. Um,
Gastón, we have a question from the audience that is they are asking if the resulting image of the diffusion with ControlNet is the same size as the input image
okay,
that we
it's
put
a
into
good
the
question.
show.
So the input model has a fixed input and a fixed output size. So you need to crop or resize your pictures. If not, the pictures are going to be resized and are going to lose the ratio. So it's better if you make it before introducing it to the model. So the answer is you need to use the specific size of the model.
Yeah, because these models are actually trained into some kind of size, right? When you do a fine tuning, for example, of the Stable Diffusion models, you have to input images in the exact size that you want them to be output, right?
Yes. You can take the outputs and use some upscaling methods to get a bigger picture, but the output of the raw output, that it's going to be fixed.
Yeah.
Okay, let's move on. So ControlNet works copying the Stable Diffusion model and locking the original weights. So we're going to work with a copy of this model. These are going to be frozen, so these weights are not going to change. And then we're going to connect the layers of the copy to the decoding layers of the diffusion model. And then we are going to train this copy with the same noise, the same prompt, and now with feature map, let's say, to generate these kind of images. So the process is similar to the original training of Stable Diffusion, but now we are touching these weights, or we are not like touching these weights, the original model. This is better because we have a small model that means we are going to make some the training very fast, and we are not modifying this model. So we can change this. Sorry, we can change this to another fine-tuned model, like the ones you can download from internet, and keep using the original ControlNet you train. So
Makes sense.
you can have this like separated.
But one question: you have to train the control net for each image that you want to generate, for each template that you want to use, or is it something that you just train for everything and then it works?
You need to train for a specific task, like you want to use scribbles, you need the ControlNet that use scribbles. You want to use segmentation maps, you need to train the ControlNet that use segmentation maps as inputs. But besides that, you can train the model to generate any objects and anything you want.
So a way to understand it could be like a plugin, right? That you can have several different plugins for this Stable Diffusion, and yeah, and you could have, for example, a marketplace of these control nets, each one trained for a specific task, let's say, and then you use the one that you need for the specific task that you want to do.
Yeah. Actually, you have a
Okay.
repository in GitHub and in Hindface with several models for several
Okay.
tasks. And the community is uploading models every day, so you can choose anyone you want.
Okay. We have another question there from the audience. They are asking, how long does the training takes for the ControlNet? What kind of specs do you need to train it?
Okay, so it depends on the size of your data, but we are using half the model, so we only have the encoding layers, so it's going to be very fast compared to the original Stable Diffusion. And you can use small models, so it can speed up more the training. And talking about specs, I don't know the hardware specs, but I guess less than or Stable Diffusion.
Okay. We have another question. Seems that this is an interesting topic, Gastón. Here we have one that says that reads, "Can you fine tune the models in your local machine, or is this specifically to the cloud? I mean, can we train ControlNet in our local machines?"
Yeah, actually, I made it on my desktop computer.
Okay.
You need a, you need a GPU that can have the weights of the models and the data
Mhm.
running in the VRAM memory, but
Yep.
that's the only requirement because it doesn't need like too much processing power. It needs memory than processing, so that's the limitation.
Okay. But I mean, you need a video card in your local machine, but you can do it anyhow
Yeah.
because it's not that hard to actually do it. These are small models, we could say.
Yes.
Yeah.
The last model from Stable Diffusion, like Stable Diffusion XL, it's very large, so it is harder to train. I guess you cannot do it locally, but you can rent some GPUs on a cloud service.
Yeah. We have another question there from Mariano. It reads, how do you manage the cloud storage and the processing? Because they say that if we have to train the model for each template or outcome that we want, then it wouldn't scale, right? Because we will need to train like a lot of models. But I mean, Gaston, let me try to reply and then correct me if I'm wrong from what I
Okay.
got from what you told. I think that what you shared just now is that if you want to use counter you will use a model trained for taking contours, right? And then using Stable Diffusion with that. And if you want to use segmentation maps, you will use a model, a ControlNet trained for segmentation maps, right? So you only need to train the model to handle some kind of templates, but not for each template. For example, if we want to change that dog, we can just use the model that we trained for the previous dog, right? Or for just contours. Okay. Yeah. Okay. We don't have any more questions, so I guess we can continue.
Okay. So there is a repository when you can download all these models. So you are going to leave the links on the chat, so you can search any model you want.
Okay.
Okay. Okay, let's move to. Oh, okay, we have some examples. For example, a model to detect some edges on the pictures. If you have a bird, a photo of a bird, we, you have you got this bird with several edges. It's like a very noisy map, but it's okay. And then the model are going to generate these copies of the bird with some style you want. And you can use other model to extract straight lines. For example, for picture of rooms or for the city skylines, you can use this straight line detector to generate this kind of maps and then this kind of rooms. So you can take a picture of your room, process with Hoch line, and then use Stable Diffusion to maybe test what colors you want to paint the walls on your room.
Makes sense.
And for example, the head boundary, it detects the boundaries of different objects on the picture. So you can take a picture of your father, for example, and generate other versions of your father.
So these are all ways in which you can just generate contours, right, from existing images. These
Yes.
are kind of different methods to do it.
Yes, different methods to extract the borders or the lines of your picture.
Yeah.
And my favorite is the scribble, where you can make a very bad scribble of an object and then ask the model to make a hyper-realistic photo and get these awesome turtles. It's pretty cool. Okay,
Amazing.
so let's move to the web app. We're going to use the automatic 1111 web app. The installation and download process are going to be in a link we are going to leave in the comments. So let's start generating some images.
Yeah. Let's go.
So
Do you have some prompts already to run?
yes, I have a pretty cool prompt. Let's work this together, but I want to
Okay.
generate an capybara astronaut.
Let's
So
just step back one second. I mean, because
yes.
this UI, this
Mhm.
is an UI that wraps, let's say, Stable Diffusion and also ControlNet, right? And puts it in a way in which we can consume it, but we can run this in code, right?
Yes. This is like a web app to skip the code part and
Yeah.
just generate with Stable Diffusion, and it allows you to install some extensions and other add-ons. But you can make it
Okay.
like by hand with the code. So
Mhm.
I have a notebook example here.
Yeah.
If we have
We
some
can
time,
go
we
there later.
can. Okay.
Yeah. Let's just generate some images so people can see and we can play around with the folks that are watching.
Okay. Okay, this prompt reads a detailed full body concept art illustration, oil painting of an anthropomorphic capybara astronaut. So let's stop here. So these are going to be a full body image, like an illustration, like a digital art, oil painting of an anthropomorphic capybara. So this are going to be like a human with a capybara face, maybe.
Yeah.
So with an astronaut full armor. And this is to help the model to understand the vision we have. So like a dystopian biomutant astronaut.
Yeah.
And lastly, we put some ultra detailed digital art octane render. This is to,
These are called descriptors, right? I mean,
yeah,
these are the ones that, for example, you use in Midjourney or Stable Diffusion. Yeah, for example, we are working with Stable Diffusion here, but Midjourney uses the same, or DALI uses the same, right?
yeah,
Yeah,
are like descriptor of the style you want. Yes.
yeah.
So let's check it's all deactivated. Oh, so spoilers.
So we are running just Stable Diffusion without anything, right?
Yeah, this is Stable Diffusion raw. We didn't add anything. It doesn't have ControlNet. So let's see
Mhm.
what we want. Okay, it's pretty good.
Looks nice. Yeah,
Let's wait. So
that's
it's pretty
amazing.
nice. Yeah. The details are awesome. Like
Yeah,
the wrinkles
quite
on
well.
the suit is pretty cool. So the quality is a little bit low, but it's because we are running the 1.5 model that have this input and output size. So it's
Mhm.
not full definition. Okay, so what's happened if we use, for example, the open pose model that extract the pose of someone in a picture?
Mhm.
I have some examples. So I have this guy standing on a B position.
Yeah,
So this is the interface that we're going to use. Here where it says ControlNet are all the options we are going to use. So first of all, make sure it's enabled. And then you need to know the pre-processing you need to use. So here we are going to use open pose. It's the pose estimation.
yeah.
So it's,
These are the ones that you showed in the later screens, right? I mean, you had
yeah,
canny and depth and yeah, etc. So this one is one that's going to extract the pose of this guy
yes,
and use that as a as the control,
yeah.
let's say.
It's yeah, are going to guide the generation image to the standing capybara with a B pose.
Okay.
So we have another options, but let's make it generate. It takes a while. So here you can set the preprocessing if you need to extract the pose of if you have the map we saw earlier. You can use none and just set the map to, and then you have the control weight. This is how much you want to affect the generated image with this model.
Yeah.
When you want to start and end the guiding of ControlNet, so it starts in the 0 and ending in the 1 means 100% of the steps, but you can change it. And then you can use the resize and crop and resize. This is what we talked earlier in the talk, that if the image is not square and it's not in the same shape of the model, you need to
Yeah.
resize this. So, oh, this is the
That was
final
pretty cool.
result. It's awesome. It
It
follows.
looks pretty good, and yeah, that's what I wanted to see. I mean,
Oh,
you have there the exact V shape that it extracted from the eye in the pose, right?
yes.
So yeah, this is the template that it's using. Let's say.
Yeah, it's a little bit creepy, but you have all these points to guide the generation.
Yeah.
So
And according to that, to those colors mean something. Is that kind of like a heat map or some kind, like because it's a depth layer, or is it something that is classified? Do you know? Do you have that
yes,
information?
the colors means any pipe. So your body are going to be described by these pipes. So for example, this green means your left arm, and the
Okay.
dots means the fingers.
Okay.
So each color is unique. So maybe it's a little bit hard to discern the
To
different
pinpoint them.
screens, but yes. But for example, the legs are these two, and this is the torso of the the
The guy.
the
Yeah.
man, yeah, we use. Okay,
Okay.
so
Can we try with another one?
yeah,
That is not posed. Maybe some kind of depth or contour.
yeah, we can use depth, for example. So I have some landscape images here. Let me take maybe this one. This is pretty cool. So we have these houses like an Asian village. Uh, so
Yeah.
let's, I don't know, just give me one style you want to
Village
change
in the
this.
Let's try something like village in the mountains. I don't know, with raining.
Okay,
Yeah,
raining.
yeah.
Okay, obtain.
And
Let's
some
use the
dogs going
same.
around.
Okay, village in the mountains. Raining, ghosts. So ghosts.
Oh, you wanted to put the effect of the.
Sorry.
No, you wanted to put the kind of the descriptors. Yeah, I got it.
Yeah, yeah.
So
I'm
you're there. You are selecting the depth mask, and what else?
so here. Oh, I leave the open pose enabled. So this is going to be a little bit weird, but
Okay.
here we are using the depth map. So we set the control type to depth, and the
Mhm.
processor depth midas. This you have several options. This is the most common one, and the model. This one you need to download from the repository. So you need the okay. You
That's
need to
pretty weird.
download.
Okay.
Yeah. you you need to download these models from the repository. Yep. In the last
Yeah.
example, we use the open post. Here is the control stable diffusion 1.5 depth. So are model specific, so be careful with that. So
Okay.
we lower the control weight because these maps are pretty aggressive. So it overrides anything in the image. And we start the guiding on almost a quarter of the generation. And we set the prompt to be more important than the ControlNet uh, map. So okay, it's pretty
Can we
weird.
see the depth map? Can we see the depth
Yes.
map that you created?
Yep.
Oh, okay, makes sense. Yeah, makes sense.
So you have like the houses, and this stuff in the front is brighter than the stuff in the back. So the mountains
So
are missing.
darker means forest, right?
Yeah,
I mean, if it's light, it's going to be closer to you, and if it's darker, it's going to be farthest from you. Yeah, makes sense.
yeah.
Um, and then it combined the pose, the open pose that we had before, and then it created this image. Yeah, pretty
Yeah.
good.
Let's make it again
That's
without
amazing.
the open pose. Yeah.
Okay. So
If you,
yeah, but this is nice because you show that you can add several layers of these steps, right?
yes, I make
Yeah.
some test and we can try it now. But if you want to combine these two units, you need
Yeah.
a depth map that in the near objects are not, you need to doesn't overlap with the pose, because you got
Okay.
this weird of humans and buildings in the same place. Okay, so we have the same like house, like this roof, and this
Yeah. Same pipe.
other is, yeah.
Yeah, like the
Okay,
contours seems like they are the same, but there are some differences. Yeah, it's nice.
yes, that's because I lower the control weight. So if we set it like in one, they are going to be more
There we have a
similar.
question, Gaston, that they are asking if it's okay to use more than one, like depth and straight lines and etc.
Yeah, you can combine multiple units. So here you have only three, but you can stack it up any you want. But be careful because this is running on your computer or in your computer. So you need to run, like, here we are using only one, but if you set three, you need the three ControlNet models, the Stable Diffusion
Yeah.
model, and you are going to need,
Oh, I got it. So you need to load those models into memory, right?
yeah.
Yeah.
So that's why the open pose plus depth map takes longer, because you have three models loaded in memory, and it takes some time.
Makes sense.
Yeah. So
Okay.
this
What
is
else?
better.
What other options do we have to control the stable
Okay.
diffusion?
So we can, for example, let's delete this. We can use a room picture, for example, like the example in the presentation.
Yeah.
Let's imagine this is my room. It's not, but and I take a picture of the room with a plant, uh, like the bed with some pillows and a small
Yeah.
table and a window. So this is pretty fun because if we set to Kani, for example, here we are using the Kani ControlNet model.
Yeah. This is
And
the one that extracts kind of like the contour, but it's like a noise kind of contour, right?
yeah, this
Yeah.
extracts like lines and contours.
Yeah.
So,
Um, can we try a bed in the forest or something?
okay.
You want,
So
if you
I,
want.
oh, like a bedroom on the forest, digital art. I always use these modifier words. It helps the generation.
Yeah, those descriptors are useful. Actually, I don't know if you already tried GPT with DALI 3, but you don't need descriptors like those anymore. It's like they allow it to just ask for some kind of images, and then the chat generates those descriptors for you.
Nice. So
Yeah.
let's close this. Okay, this is the room. It is in the
Oh,
forest,
the forest is
but
outside.
the forest is outside the room. Yeah.
Can we just put a bed in the forest to see if it
Okay.
generates like the
So,
forest, like the bed in just the forest?
yeah, I guess it doesn't going to work because the map have the walls on it. So
Okay,
I
could
leave
be.
this. So let's wait. Okay,
It worked.
it
Nice.
worked.
That's amazing, actually.
Yeah. Nice.
Okay.
Good
So
business
actually,
case.
you can do this. You can do all of this. Actually, sorry, we have a question there.
Okay.
Do you know, in average, the file size of the trained control nets? I mean, each of these models that you have there, for example, the Cani or the Contour or the other ones, how much do they weigh?
The bigger ones weights like maybe 3 GB, but there are some small versions, and you can use the C2 adapters that are around maybe 200 megabytes, are very light.
Okay, so around 200, let's say.
Yeah.
Okay,
So
that's
I remember I used the just resize. So let's change it to crop and resize and burn, and let's check what it generates. Uh, I like the blue one, so I'm going to make a blue colored bedroom. Make it modern, why not? And hyper realistic.
put it futuristic, so it's
Okay,
something weird.
futuristic. Okay.
Yeah, we can actually ask some prompts from the audience. Let's say if they want
Yeah.
to
So
leave some prompts. But the idea of this, Gaston, is that you can actually run this by code, right? I mean, if you, let's say that you want to build an app with some kind of pipeline in which you want to take images and then generate some kind of variations of those images, let's say,
yeah.
you could put like several models in a series, right? And be applying these kind of transformations and control net stuff.
Yeah. You can use it with code. It's a little bit harder. You need to instance all the preprocessing you need. For example, this Cani, Def, OpenPost, and you need to manage yourself. But you can, yes. If you have a pipeline, for example, of an app, you can. So this is the blue colored room. I don't know if it's futuristic, but it's blue. It's modern.
That thing in the wall that is glowing is weird, so could be
Yeah.
futuristic.
It's awesome how the blanket and with the wrinkles, it's the same as the picture. The quality is awesome. So
Here we have a query for Pixar style. I don't
okay,
know if
let's try it.
maybe try to create a child bedroom in Pixar style.
Okay, like child bedroom Pixar style. So there is a web page where you can look for prompts. It's called
Yeah.
Lexica Art. So you can search there for this kind of prompts of Pixar. Maybe there is a keyword like, I don't know, the name of a movie, and it helps
Yeah,
a lot to.
I remember that there was one for actually Midjourney that had a lot of styles in which Midjourney had already been trained. So yeah,
Yeah. So it's a little bit
is that
Pixar.
Pixar?
Yeah, I don't know. It's
Kind of.
kind of close enough.
Yeah, like Monster Inc. could be good, but yeah, but you had some code right to show how this could be run in a pipeline, let's say.
Yes, I have this notebook. So here we have the explanation of this work. If you want to deep dive on the real connection of the layers and the Stable Diffusion model. And you need to install the requirements. So,
And what does this use? Is it use transformers in order to run the Stable Diffusion model? And what else?
and the diffusers library
Yeah.
that have the Stable Diffusion pipeline, and this Stable Diffusion plus ControlNet pipeline
No.
that
Okay.
you
Makes
can
sense.
like use Stable Diffusion plus ControlNet all together. So here you download this picture, and for example, in the web app, you just set to Kani and the Kani model, but if you made it by code, you have to instance the Kani filter from CV2.
Yeah.
So this is the map, like the ones we saw.
Yeah.
And then you have to instance all the models, like the ControlNet from, this is the original repository. This is the ControlNet
Mhm.
for Kani, and the Stable Diffusion, the 1.5, like the one we using.
Yeah.
And then, okay, you have to set some parameters, and here you set the prompt and some conditions to the prompt. And with this, you just start the generation, and this is the output.
That's nice. Oh, can we see the prompts that they run? Are they characters? Because that one looks like
Yeah, it
real. Yeah,
says
that's real.
Sandra, yeah, Kim Kardashian, Taylor Swift. These are famous.
That's amazing.
Yeah.
So good. Okay.
So, like the in the workshop that Fede made,
Mhm.
we can say the Mr. Potato Head examples. So, for example, if you have a Mr. Potato image, you can make this weird
That's
Mr.
great.
Potato. But you can take some, for example, yoga poses and use open pose to extract the poses
Yeah.
and generate some like superheroes.
Doing those poses. Yeah, makes sense.
Yeah. Okay.
Okay.
So
That's actually amazing. I mean, yeah, you can create a lot of things with this because when we had already tried to build some pipelines with images, um, and the issue is that you don't have that much control, right? Like the same for LLMs. Let's say that you want to create some kind of JSON output and have it structured the same way always, then it becomes a little bit hard, right? So if you use something like guidance, right, where
yeah.
you put some kind of template that the LLM has to fill, then it becomes more useful. Let's say. So let's say that ControlNet is some kind of guidance for Stable Diffusion
Yeah.
as a guidance for LLMs. Yeah.
Or yeah, it's like another way to guide the generation of content.
Yeah.
So I have some other examples I want to test. So maybe you remember the old squint your eyes memes from internet. So like this of Pepe.
Yeah.
So
That's clearly a Pepe.
you can use Stable Diffusion plus ControlNet to generate these funny images. Like, so let me disable the other. For example, if I have this spiral and I want a village generated with this spiral embedded on the landscape, I can
Mhm.
use so let's say to all, like the QR code monster. That this model takes the black and white of an image and like make a condition, but a very soft condition of the final image. So let's take, for example, a medieval village digital art Octane render, and let's see.
It's amazing that. Do you know what Octane render is? Octane render is, or do you
No,
just like?
I just steal it from Lexicart, but I don't
Yeah,
know what it is.
yeah, that's
Yeah,
amazing. I mean, there are a lot of those of kind of the descriptors that we use, and we don't know what they are actually they actually mean.
I love the names of like famous artists that I don't know. I don't know the style, but you can use it to generate some. Okay, so we use this spiral, and maybe in big it doesn't show very
Yeah, I
well.
mean, if you
But
squint your eyes, as you say, you can see the spiral somehow in the contours of the buildings, for example,
yeah,
and the
and
cloud. Yeah.
this is pretty low, but you can make it like a little bit aggressive.
Hmm.
So
We have a question there. It
okay,
says, if what do we think about the replicate or any similar services? I think that replicate is the service that you can run models at scale in on cloud. Have you ever used them, Gaston?
I only use it locally and on Google Colab, and that's
Yeah.
the
All
most
right.
cloud service I run these models. But I when this when Stable Diffusion was announced, I test some free web pages that host the service and are pretty good. The best of those services is that they have a very friendly interface. This is maybe a little bit intricate to start using, but
Yeah.
that's the
That's
advantage.
the spirals there are a lot more clear. Yeah,
Yeah,
you can see. And it's amazing how the model actually does it right, because it created like paths and then
yeah,
smoke, some kind of smoke in the sky, and then the stairs. Like it makes sense, right?
yeah. So
Uh,
it's the clouds and the path are the same trace, but
yeah,
it doesn't merge into one thing. No, so it's weird, but
yeah,
it makes sense.
exactly. It makes sense. Yeah.
Yeah. I have some other examples for. Let's use, for example,
Coming back to the
the.
question about
Yep.
replicate, yeah, if you want to just continue with that, I will just reply the question from the audience. Coming back to replicate, we haven't tried it. I guess at least I haven't tried it, and yeah, Gaston here. So I wouldn't know what to say, but yeah, these models actually is like Hugging Face, where you can just host your models on the cloud, right? And these services are there. It could be useful if you want just to run these models there, and maybe I don't know if they, for example, allow you to train the models. Um, but what we, for example, have experience with is to use them on cloud, like using SageMaker and training models there, or maybe using just EC2 instances and running the models inside. So
Yeah.
yeah, it's kind of the same, just that Replica has a lot more of. It's easier to use. Let's say
Yeah. The
that.
advantage
Then
of the yes,
yeah,
the best of these services is the the friendly interface they have is the best. So this is the, the
counter.
Lenny, like the counter of Lenny, and Here is clearly Lenny hiding in this street and the clouds. And here we have like a, I don't know, it's like the window is broken with the contour of Lenny. It's
That's
awesome.
amazing. I mean, this could be really useful for marketing, actually, right? Because, for example, when we saw first ControlNet, we saw these QR codes being generated using Stable Diffusion and ControlNet, right?
Yep.
So you can just create, for example, some presentation card that you can share with your name, etc., and just a QR code and some kind of images, and they'll share that, right? And if you're a digital creator, that could be actually quite good.
Yeah.
But yeah, for marketing, for example, for marketing purposes, these control nets could be amazing because you can just generate images at scale, actually, right? In the style and in the shape that you want.
Yeah. If you have a fine-tuned model with your, I don't know,
Style,
your style,
yeah,
you can make it. You can use it with this QR code ControlNet and make some amazing stuff.
yeah.
So I
Do you have
have
a QR code lying around?
no, I have some black and white Lenio logos, but I don't have any QR code.
Let me try to generate one. If you have any other image, though, you can run it. But let me try to generate one,
Okay.
and maybe we can close with that one.
Okay.
Um,
If someone wants to send a prompt that we
yeah,
can use, there's no
please.
problem. So I have the logo of the Leniolabs, and I'm going to cheat a little. I'm going to change the resolution to the logo. And here it says if the colors of your image is with white background, you have to set the preprocessor to invert. Let's just use it. Okay.
I actually don't know how to send it to you, but maybe you can open this page that is QR dot. Let me check it. Just found one that is QR.io, and we can create one there.
Okay. Let me move to here.
Let's just generate something for
Like from Lenio, for example.
yeah, sure.
Okay.
That's it. I think that you guys, yeah, when you try to download it, it's going to ask you for something, and if you save, it's going to save an HTML because apparently they have something weird there. But
Oh,
you can
okay.
just take a picture of the screen, and that's it.
Yeah,
If
that's right.
you, yeah,
Let's use this one.
yeah,
Going
that's
to be
amazing.
better. Let's put it
Is it
here.
better if you leave a contour around the QR, or does it have to be like,
I'm going to make it square, so
yeah?
it helps a little bit.
Oh,
There,
because you're generating square images. Yeah, makes sense.
yeah. So there. Let's make it
Okay.
center capture. Okay. So
Oh, that's great.
yeah.
What do you use
So this is
to?
it.
Oh, okay.
I use this logo. So if you squint
Okay.
your eyes, oh, it's clearly red. It's
Yeah.
Leniolabs. It's awesome. I love this. So
And you generated that image. I mean, and you're still running 512. Oh no, you generated
I
100.
yeah.
Okay,
So
makes
this resize the image to the original shape and then resize again when the output is ready to the this shape.
okay, makes sense.
It's better if you don't resize the image, but in this case for a test, it's okay. So we have the QR code. Let's come back to Okay, white background, it's okay. And okay, let's keep with medieval stuff.
Sure.
Yeah, but we can use anything you want. So
Yeah. Yeah, I mean, it's just for the example. We can
yeah,
share all the links later and leave it there. Actually, we already shared both. Yeah. So if they want to play around with this, they are going to be able to.
okay, okay. Let's wait some.
Let's finish with this one and see because it's already
Yeah, it's
hour
time.
of streaming. Yeah.
Oh, I forgot to change the shape.
Oh, I
So
thought that it was going to be automatic.
no, I forgot it.
Okay.
Okay, so this is a reshaped QR
It's
code.
controller. Yeah.
Maybe it doesn't work, but so let's
Let's see.
wait for
Let's see what
okay.
happens.
Yeah. Okay.
Pretty weird. Yeah.
Yeah. This is the QR code.
Oh, because it kind
It
of cropped
was
the QR. Yeah.
yeah. Let's make just resize so it doesn't go cropped, but the shape was okay.
Okay. So everybody, we are just finishing up with this latest render. So thank you for coming and thank you, Aston, for this talk. We hope to have you again here sharing your knowledge. So please, whenever you want, feel free to come back to the AR workshops.
Okay. This is
And
the final.
um,
Yeah.
it,
I
it's
guess it.
it's not that good, right?
Yeah.
Maybe you need to put a little bit more of weight of the contour.
Yeah. Maybe. Yeah.
Let's try that because if we can make it like yeah, I want to be able to actually scan it and for it to work. That would be great.
Yeah. I guess it doesn't going to work, but
I think that you need some kind of really high contrast for QR codes, right?
yeah, the examples I saw on internet doesn't okay.
Okay, that's weird.
Doesn't was with very complex stuff. Was was one very simple, but
I'm going to try to scan it when it finishes.
okay. I I'm guessing it doesn't work, but
Let's check. Nah, it is not picking it up. Yeah, pretty weird. Yeah, pretty weird.
yeah,
Maybe because it needs a lot more context, a lot more contrast
yeah.
on the
And
actual.
the prompt is pretty simple. Maybe you need to make a little bit of prompt engineering. But
Yeah.
okay.
Okay. Again, thank you again for coming to the AI workshops, and thank you everybody who was tuning into this live stream. We will see each other in a few weeks.
So thank you.